Hi, in my last video, I made an induction heater using a ZVS driver circuit, and now I want to see if I can use it to generate super high voltage. But this circuit is a piece of junk as is. The other day I was trying to just turn it on casually and it blew up. This is the original schematic of the circuit, but I already had to improve the gate supply voltage by adding some filter to it, and yet it blew up. See, this circuit draws huge amounts of inrush current at power up, and it powers up as soon as you connect it to the power supply. And when I connected it to my battery, I was like accidentally connecting and disconnecting the battery during those critical times, and it blew up. So basically what I did, I added a simple circuit to the original design that keeps the circuit off for a couple of seconds, and hopefully during that period the power supply fluctuations have gone away and the circuit can power up safely. So far the circuit has been pretty happy with my tiny addition here, but I really prefer a proper soft start. I don't like the fact that when it turns on at full power. Now when initially you power it up, there is nothing, and then boom, it powers up, and then you can start cooking metal with this circuit. Now, as a fan of super high voltage, I'm thinking I can replace my coil with the primary of a transformer with huge winding turn ratio and create a super high voltage at the output. I do have these transformers from some old tube TV that are made for the same purpose. I'm not a super fan of these because these have a bunch of diodes at the output to rectify the AC. I want pure AC, but hey, whatever. Well, this transformer has its own primary, but I don't want to figure out which pin it is, so I wound my own coil, 6 turns around the same core. So now I remove the big coil and replace it with the transformer, and now we can ask the important questions. Would it work? Well, let's power it from my power supply so that it's current limited. Here we go. Is it on? So much current and it's rising. Is there any arc? Oh, look at that! Whee! Interesting, when it arcs, the current goes down a little bit. Arcs! Arcs! High voltage arcs! Look at these arcs. From the space of the gap, when it just starts jumping, I would say the voltage should be around, I don't know, 5 to 6 kilovolts. Oh, holy shit, what's going on? Oh, no! Come on, turn off! My alarm is gonna sound. No! Okay. I don't think it got to the sensor. Whew. I really need to add a powerful vent to my room. Why did the transformer start to burn? Not my windings or anything, the transformer itself. Maybe it was arcing internally and melted? That would explain why the power supply current was so high if it was arcing internally. And when I started arcing externally, the internal arc would go away, and that's why the current would drop. Maybe? Maybe the frequency at which the circuit oscillates is not good for the transformer? What is the frequency actually? Let's do a quick check before the transformer goes flame on. There we go. It's 29 kilohertz, which is good. Now that I think about it, the higher we are above 20 kilohertz, the better it is. Not for the circuit, but for myself. If you remember my graph of pain versus frequency, below 20 kilohertz, the current still messes with your nerves, so it becomes very dangerous. Especially at such high voltage, if I get shocked at low frequency, it could be the end of me. So it's good that it's 30 kilohertz, but maybe I should even rise it further, like 50 or 100 kilohertz. Why is there so much wire under my chair? The design criteria for this circuit is different now. For my transformers, right now I'm driving 20-30 amps through the primary. I don't need high current, I need high voltage. I need to increase frequency to reduce current, so much less capacitors. I don't need beefy transistors, but high voltage one. Low input capacitance so they can switch faster. I have to put it together again. Let's do it. Oh wait! Like I mentioned, these transformers have a bunch of diodes at the output that rectifies the AC. So it doesn't matter how high you raise the frequency, it would still have a huge DC component at the output that would shock the shit out of you. Forget about it. I have a couple more of these transformers. Let's use one that's not burned with the same circuit. Here's another fresh used one with 5 turns around the core. Let's turn off the lights and see if you can see any arcs out of it before it burns in smoke. Okay, here we are. Ooh, it's making some noises and it smells like ozone. But it's only drawing 1.6 amps. So the other transformer was broken and probably was arcing internally. That's why it just burned. Let's try it out. Oh! Oh my god! Look at the arcs! They are huge! How much current is it drawing? Wow, it's current limiting the power supply. It's drawing over 10 amps and the power supply level is dropping to 6 volts. You know what it means? We have to power it from a battery. No more current limit. And we've got the power. Wow. That's what I'm talking about. Look at this! Look at this! Arc! I was always looking for these arcs. Oh, wait, what's going on? Oh, it's arcing to itself! Hey, wait! Oh, jeez. Never mind, it seems my wire was too close to the core and it was arcing from the wire to the core. Look at this. Wow. So beautiful! Now what can I do with this? Too bad it's rectified, otherwise I could use a multiplier circuit and increase it to gazillions of volts. Since it's jumping over 2 centimeters, I would say it's somewhere around 30 to 60 kilovolts. Well, I'm talking about the initial jump here. Initial jump. It doesn't matter how far you can stretch the arc. It's that initial distance that tells you approximately how high the voltage is. Actually, there is something called Mark's generator that uses spark gaps to step up high voltage, rectified high voltage to millions of volts. Maybe I should make one of those. Yeah. Why is it changing color? Things are burning. Good thing I unplugged that fire sensor thingy. And of course, as always, don't try this at home, okay? And if you want to know how I made that ZVS circuit, go to my previous video and watch that.